Okay, this is Mr. Peterson. We're continuing the review for Chapter 2, Part A. And I'm going to be doing problems 21 through 28. However, I've already done 24 separately on a different video. Okay, so up here we're supposed to come up with a domain and the range in both set builder notation and interval notation. And you want to draw yourself a little sketch. This is an upside down parabola because of this negative sign, so you draw the frowny face version. And you want to label the vertex, which is at negative 4, 18. Kind of had to squeeze that 18 in there, but that's an 18. Let me write it better. Okay, that's your vertex. And let me discuss the domain of this one, and it's going to be easy to fill in on both of these. This parabola stretches forever to the right and forever to the left and everywhere in between. So the x values in this thing stretch forever, right, left, and everywhere in between. We would say that it's all real numbers, and this is the easiest way to write that. It stretches from negative infinity on the left to positive infinity on the right. And I'm just going to make a quick note about this. You always want small numbers before the comma and bigger numbers after the comma. In other words, if you got two numbers, they should go from least to greatest as you read it from left to right. Now, parabolas always go forever to the left and forever to the right. So I haven't even looked at this next problem, and I already know the answer to the domain. You'll never get another answer other than this one for the domain of a parabola. So if you can remember that, that's going to be an easy problem on the test. You just fill in that answer. Okay, it doesn't change. Now let's shift up and down. The range is the y values. So if you look at this, the y values go forever downwards on this thing, but they do not go forever upwards. They max out at this 18. So we would say that the set of all y values such that the y values are less than or equal to the 18. They stay below the 18. And that would be from negative infinity at the very bottom to 18 at the top. And we include the 18 because it actually goes through the vertex. That's part of the graph. So you want to put a square bracket there to indicate that the 18 is part of the range. Okay, let's do the same thing here with the positive number up front. You get the smiley face version. Right side up opens upwards. And here you've got 2, negative 7 for your vertex. The domain we've already discussed is all real numbers going from x equals negative infinity all the way to the other side, positive infinity. So that's done. And we're going to shift our thoughts to the up and down direction. Okay, the y values such that y values go up from negative 7, so they have to be greater than negative 7, or equal to, because we actually see that the vertex is part of the graph. So this time the smaller number is negative 7, and it's included, and you go forever upwards towards infinity. So that's how you write the interval notation. Okay, number 23, what you're going to do is take this standard form equation and rearrange it. Instead of ax squared, I'm going to turn those around. And instead of adding b times x, I'll add x times b. And instead of adding just c, I'm going to add 1c. So these are minor changes. You can see I just turned the multiplication around, and here it said times 1. And I'm also going to put the y on the far side. And this is the template we're going to use to fill these in. So in front of the a, you put the x squared. So let me fill in the a column here. I'm going to square all these numbers. They turn into positives when you do that. So negative 4 times itself, negative 1 times itself, and 5 times itself. Then in front of the b, you put the x values. So I repeat these, but this time you just copy them. Negative 4, negative 1, and 5, which you have to write as a positive 5. And that fills in the b column. And then 1c is static, so we're going to go plus 1c equals. You don't ever use anything except 1 in front of the c. And then we fill in the y values, 3, 16, and -8. And that's how you do that problem. There's actually a lot more work ahead, but you don't need to solve it. So you would have to solve this thing, which takes about a half page of work, but you're not supposed to do that on this test. Okay, now I got 4 problems at the bottom here that we're going to have to factor. And the first thing you always look for when you factor is a common factor. So I'm going to pull out the biggest number that goes into all these, and it will include an x. So I'm going to go with 6x divides into all these. So if I go 6x into 18x cubed, you divide this by this and you get 3. That'll give you 18 and 2 more x's. You can see that would give that. This divided by this is going to be plus 5x. And then 6x divided by 6 gives 1. You could check that line by distributing, and you'd be back up there. Now I'm going to see if I can factor this trinomial. I don't think it's going to work. I think we're going to be done with this problem, but let's try it. Your leading coefficient is 3, and it goes on the wings. Multiply that times the 1 at the back. And put the 5 underneath it, so you can see I've got those numbers in there. I'm trying to find 2 numbers that multiply to give 3, and I had to give 5. Well, the only way to get 3 multiplying is 3 times 1, and that won't help us. We're trying to add to give 5. So since there's no possibilities here, that didn't work, and that was the only possibility, we were actually done factoring it when we pulled out the greatest common factor. So that is our answer. On the next one, the common factor is 3, and to see that, you're going to go 108 divided by 3. Make sure 3 goes into that, and it does, 36 times. So you're going to pull out the 3. This divided by 3 is 25x squared, and this divided by 3 is minus 36. Okay, at this stage, you should recognize that you're dealing with perfect squares, this being 5x times 5x, and this one is 6 times 6. And you got a difference between them. So this is called a difference of squares problem, and they're very predictable. You put those square roots that I mentioned earlier in. That's what you multiply to get the first part of it. That's what you multiply to get the second part, and it's automatic plus and minus sign to finish it. Now to show you there's no middle term here, you can see there's a 30x there. You also have a negative 30x. So the middle term cancels out, which is why these problems always look real short. There's no middle term. This one is a trinomial, so we're going to have to work with it. And the common factor here would be an x, and I think we can get 3 out of each of these numbers. But with a negative in front, you want to pull the negative version of that out. And if you distribute here, you'll get that. If you distribute here, you'll get that. And if you distribute here, you'll get that. Now what we have here is perfect squares on the ends. And we have to see if this middle term is right, because it looks like we've got a perfect square trinomial going on here. 3x times 3x, 2 times 2. And if you take 3x times 2, that's 6x, and double it, you get the middle term. So this is perfect. You're going to say 3x times 3x. 2 times 2, and when you do this, you always bar the middle sign on both of them. So we'll write it like this to be done with it. And if you're checking your work, you're going to go 1.23 or some other random number. Store that for x. Type the original. And find out how much that turns out to be. And then type your final answer here. And they should match, and they do. So this is done correctly. Or at least we didn't make a mistake. If you check this line, it would check, and you might think you got it right, but you're going to be marked wrong for not finishing the problem, and the calculator won't tell you that. Okay, the next one here has a common factor of 2. So we're going to pull that 2 out. 34 divided by 2 is 17. And I divided all 3 of them by 2 to get these numbers here. And I'm going to see if I can make this work here with a star. So let me set this up. I've got a 15 in the front here. And 15 times -4 is -60. We want numbers that add up to 17 and multiply to give -60. So let me get this going here. If you go to your y equals key and type in 60 divided by x, set up your table to start at 1 in automatic mode, then go to your table. You can see the factors you have to work with. Now, getting 17 might be this 3 and 20, but it could also be this 5 and 12. The key here is that we have to use opposite signs. So this is the only one that's going to work here. 3 and 20, and you make it opposite signs. The other one down here, you'd have to use -5 and you'd have to use 5 and 12, but those don't multiply to give -60. All right, so this becomes 5 over -1, and this becomes 3 over 4. And so you end up with 5x minus 1 and 3x plus 4. And that, when you check it, let's see if we've got the right answer here. So I'm going to quit to the home screen, store a random number, and type the original. And type the answer down here, including that 2 that's needed. A lot of times students will leave off the common factor in the problem, and you got to keep it there. We get the same both times, so we've checked that answer. It's the correct answer. And that does it for problems 21 through 28, 24 being on a separate video.